guys, what we're going to do in the next few lessons, do a little bit this week, but we're going to carry on next week, is the revision exercise on page 171. Let's be honest with you guys, this is a revision exercise which includes all the stuff that you need to know from Euclidean for this year, okay? And we are starting to looking at, start preparing for the test, which will be next week on Thursday, okay? Next week on Thursday, I think it's on the 25th of June or something like that. So we start thinking about that, and this exercise, we're gonna work on this revision exercise a lot, because I had a look at some of the questions and they are a bit difficult. We got to remember how to use quadrilateral triangles, properties of trapezium, of parallelogram, rectangles. Okay, we've done that, and then we moved on to congruency, which is difficult. Similarity, okay, which is even more difficult to some extent. And some of these problems mix all these topics together. So there's no other way other than just doing it. Okay, so I'm going to solve quite a lot of these exercises, or a few of them anyway, and I want you to have a go at the other, or listen to first of all the way I solve them, then do the other ones that I give you, and don't give up, don't give up. If it doesn't work, spend some more time on it. I'll give you more time, okay? These lessons, I'm going to give you some lessons just to work on them. And then if you don't get it, before you call me, check on the memo, because it might be quick. Okay? You just have a look at the memo, and that you might understand what they're doing there. Only if you don't understand how they solve the memo, then please contact me on WhatsApp and we'll go over it, okay? So the first exercise, and please, I want you just to pause me now, get the book, and read it with me. Okay, so we're in page 171 and we're doing example A. Okay, so there's no congruency here. This is like just your simple working with a parallelogram, okay? So you're told there's a parallelogram A, B, C, D. You're told that these two sides are the same. These two angles are the same, okay? They say that AE, this is E, AE bisect angle BAD, meaning A1 is equal to A2. They tell you this is 60, and the first bit you want to find out, and this is 90 by the way, and I want you to find out E3. E3 is this angle, okay? How do we do it, okay? It's not easy, okay? Now, one of the things in the parallelograms that you know is that opposite angles are equal. So you can say angle C is equal to angle A because it's opposite angles in a parallelogram. Parallelogram, we just write P-A-R-N. Okay? Now, C is 60, so that means A is 60. Okay? But now we know that A1 is equal to A2. Okay? We know that A1 equal to A2, that was given. Okay? Because we told that this line bisect angle. So that means that, which way will I go? Yeah, I will go that. So A1 is 30. Okay, so this is 30. Okay? Now, if A1 is 30, I can also say, let's not give it a, yeah, okay, so this one's D1, this is D2. Therefore, I know that D1 is also 30. How do I know that D1 is also 30? Okay. If I know these two sides are the same, the opposite angles will be also the same. So what did we call it? Opposite angles to equal sides. Something like that. Opposite angles to equal side, the opposite side equal angles. It doesn't matter what you write, you'll get the marks. Okay? So opposite angles to equal side equal. Okay? Right. So we know this is 30. But now if we know this is 30, then I can find out E2. Okay? E2 plus 30 plus 30 must be equal to 180. Okay? Very important. One of the most important properties. Sum of angles in a triangle. So therefore E2, I'm going to make it quick. You guys can do it in a couple of stages, but this is 60. So E2 is equal to 120. Yeah, I just solved for E2. But, you know, you can move things around, but you get E2 equal 120. Now, if I know E2 is 120, and I know E1 is 90, now I can figure out E3. So E3 plus 120 plus 90. How much all the sum of angles around the point is? Correct, 360. Okay? So sum of angles around the point. We haven't used that much this year, but we did use it more last year. Okay, so sum of angles around the point is 360. So what you get is E3 is equal to, that's 210, 250, right? 210? Yeah. 210, 150. E3 is 150. I hope I got it right. 210, yeah. E3 is 150. Okay? So that's your first part. We've done. Next, we are asked to calculate the value of x. So that was the first part of the question. Second, can you still see far right here? Yes. We're trying to find x. So we're looking for a shape where the x is. And check out, I'll just highlight it in red. I'm going to look now at this quadrilateral. Some kind of strange quadrilateral. It doesn't matter. It has four sides. I have E3, which I know now is 150. I've got 60, and I've got a bunch of stuff with x's. What is the sum of angles in a quadrilateral? 360. So I'm just going to add them all up. I'll say, okay, 3x plus 30 is this one, plus 60, plus 2x plus 20, plus 150, all that equal to 360. Okay, so I was looking for where the x is, and the x, all the x's are in this quadrilateral. Add them all up, because I just have x's as numbers here, and that will be equal to 360. Obviously, I need to give a reason. I'll write the reason here, even though I should write it there. I ran out of space. The reason is sum of angles in a quadrilateral. In a quad. You can write quad. Okay? Now, that's an equation that you can all solve. Not a problem. 3x plus 2x is 5x. Plus 30, 60, 90, 110, 260. I hope I'm not making a mistake here. 360. Now I'm going to do minus 260. So I'm going to have 5x equal 100. And that means x equal 20. Okay? So, still not difficult. The last one, which is actually even easier, only the first question was tough. They asked me to prove that D2 is 90. They wanted me to prove that this is 90. But look, if I know that D2 is 3x plus 30, okay, it's given, I guess I can write. But now I know x is 20, so it's equal to 3 times 20 plus 30. Okay? That's equal to, it is equal to 90. And remember, we always have to give a reason. So I just proved that x is 20, so I need to write proved or proven. Okay? I just proved that x equal 20. That's why I can substitute 20. And that's it. Okay? So I'm going to just pause here and see if there's another question that maybe I should just do now before I send you to the exercise. Okay, so guys, I thought a little bit about that. And questions are tough here. So what I will do is, I'm going to ask you to do for this little question, for this little lesson, I want you to do B and C. I solved A for you. We're in the revision exercise, page 171. So I've done A for you. I'd like you to do B and C. But what I will, and so pause me now, I'm doing B and C. But what I will do now, I will show you the solution of B. So try B first. Okay, try B first. Have a go at it, even if you don't get it completely, but see what you can get on your own. And then if you really didn't get it, just start the video again, and I'm going to show you B. I'm not going to show you C. C, you're going to have to check the memo if you can't get it, and if you still don't get that, you'll have to contact me. Alright, but very important, you have to go at it first before you listen to how I do it. Otherwise, if you just listen to where I do things, you might say, okay, I understand it, but it's not the same thing. If you haven't had a go at it, you didn't fully understand it. Okay. Right, so I've got a shape here. Okay, some quadrilateral. And I'm told this is 75, this is 20. This is x and this is y. Those two sides are the same. And those two sides are the same. And I want to find out x and y, first of all. Okay, so the trick is to figure out, okay, which triangle am I looking at? And the triangle that you're looking at, you want to see as many numbers that you already know, and just the letter that you want to find out. So we'll start with x. It's always you want to start alphabetically. So you do the x before the y. And check out this triangle, the one I'm highlighting in red. Okay? In this triangle, I've got angle x. I've got 20. I don't know what that is, but I've got 75. Now this is something that, what is that 75? What do we call that angle? It's not in the triangle, it's outside, so we call it external angle. Okay? So 75 is the external angle to this triangle. Okay? And what do we know about external angle? It's equal to the sum of the opposite internal angles. So 75 will be equal to x plus 20. Okay? Because these are interior angles, and they're opposite to the angle which is just on the other side of the 75. So x plus 20 equals 75, and we're going to write down external angle equal to sum of opposite internal angles. Okay? So very quickly we can see that x equals 55. Boom. Okay, x is equal to 55. Now, if I know that x is 55, it does, to me, it helps to actually write it down there. Now I want to find out y. Y is, if you can see very easily, y, or what letter is this? F. F2 is equal to y. Right? F2 is equal to y. Okay, because they are, well, let's write it down. F2 is equal to y because these are vertically opposite angles. So now let's look at this triangle which is highlighted in red now. Okay? I know this is y, I know this is 55, but I know C3 is also 55. How do I know that C3 is also, or C2, sorry, let's see C2, this angle. C2 is also 55, and the reason this is also 55, because in this triangle, that's an isosceles. These sides are equal. So these angles are equal as well. So angle or equal angles, opposite, equal sides. Okay? So now in this triangle, this red triangle, what is the sum of the angles? It's 55 plus 55 plus, we just knew that this is y. 25. Okay? So the sum of the angle is 180. Okay? Sum of angles in triangle. You're always going to have that property somewhere. Okay? And then that means 110 plus y equal 180. Y equals 70. Okay? So we found x and we found y. Okay? Now the next thing they ask us, prove that ABC is a trapezium by using 3 different methods. Let's just use one. Okay? Let's just not worry about 3 methods. Let's just use one. So I'm just going to make some space. Okay. So we are asked to prove that this is a trapezium. Now, what is a trapezium? What is the definition of trapezium? Trapezium is basically a quadrilateral where there's one pair of sides that are parallel. Okay, which one are going to be the parallel one? These two. These are obviously, you can see they're not parallel. If you carry on extending them, they'll meet each other. But these two lines, they look at least parallel. Okay? But I need to prove that they're parallel. How do we prove that lines are parallel? Well, we need to find that 2 corresponding angles that are equal, or 2 alternating angles that are equal, or 2 cointerior angles that add up to 180. Now, what I'm going to try and show, okay, I want to show that if this is 55, I want to show that this is also 55. I want to show it. I don't know it. That's why I'm putting question mark. I want to show that this is also 55. How am I going to do it? Look, I know that y is equal to 70. Okay, we just proved it. Okay, so I can write down 70. What else do I know about this triangle? AFB. Okay? I know it's an isosceles. Okay? It's an isosceles. Okay? So if I call this, let's say, well, don't need to call it. Yeah, let's call it Z. Okay? Let's call B2Z. Okay? B2, let's say we call it Z. Okay? That is equal to A2. A2. Why is A2 also Z? Because these are equal angles opposite equal sides. So equal angles opposite equal sides. So this is Z. This is Z, this is Z, and this is 70. So we're going to say Z plus 70. You see me here, you can. That must be equal to, correct, 180. Sum of angles in triangle. I told you, you're always going to have that at least once in every problem. In a triangle. Okay? So 2Z, I'm going to move already the 70 to the other side is 110. So Z is equal 55. And that's what I wanted to prove, right? I wanted to prove that that B2 is 55. So how do I know from there that these lines are parallel? I'm going to write it down here. Okay? If this is 55 and this is 55, so what we've proven is, therefore, E2, angle E2, is equal to angle B2. Okay? Just proved it. And therefore, can I write below it? I can. Then I can say, okay, AB parallel, this line is parallel to EC. I have to write a reason, and the reason is that I just proved that we have two pair of alternating angles that are equal. So I'm going to write alternating angles are equal. If I've got a pair of alternating angles that are equal, therefore the two lines are parallel. It's the converse, it's the reverse theory. Okay? Right. Okay, hopefully you got that. I want you to try and do C, check the memo, and that's it for today.